Okay, welcome. We're going to talk about how to find the interquartile range. Yeah, that's a fun one. Interquartile range, otherwise known as IQR. Now, interquartile, that implies that there's quartiles, quart being 4, and we're going to look at the middle 2 of the 4. So we're really looking at the middle 50% of the data. So the interquartile is the middle 50% of the data. And remember, it's a range, so it's going to take the distance from the minimum to the maximum. Now, first thing we need to do, if you're going to split anything into 4 parts, the smartest thing to do is to split it in half. And I can already see my mean, but don't confuse that. That is not necessarily halfway. Mean, at where the triangle is, that is just the average. That's not the median. So to find the middle strategy I see a lot of students use is we'll take one off from each end until we get to the middle. And I know there's 30 data points, so I'm going to be going to that 16th point, but we'll just cross one off along the way. Sometimes on these dot plots, there's one that sneaks in from behind, like that guy right there. Don't miss that one. All right, and I lost count. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So 8, 9, 9, 10, 10, 11, 11, 12, 12, 13, 13, 14, 14, and here we go. So, and actually my median does end up being right at 55. So pretty close to my average there, 55.03. It's extremely close. So that can happen, that may not happen. So just be careful that you not mistake the mean for the median. All right, so I've split that in half. So my halfway point is going to be, draw this in blue. So right here, that's half. So now I have 2 halves, but I need to split those halves in half so I can get quartiles. So I'm going to cross off my black line so I don't make a huge mess of my work here. All right, so I've got 1 and 1, 2, 2, 3, 4, 5, 6, 7, 8, and 8. So what that's showing me is my halfway point is actually right there in between those 2 points. So this point here, this looks like it's 42. This point here is 45. So what is halfway between 42 and 45? Well, that's 43.5. 43.5. So there is one quartile, starts here to here. So here we're going to call this quartile 1, or the first quartile. It can be labeled both ways. This is going to be quartile 2, the distance from 43.5 to 50. So that's quartile 2. And now I need the same thing up here. So I have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. All right, so my second is going to be between 70 and 70, which halfway between 70 and 70 is still 70. So that means that's the division of the upper 2 quartiles. So here's quartile 3, and then lastly, here's quartile 4. So again, we just found those 4 quartiles by taking what is the halfway point, and then what is the halfway point of each of those halves. Now, the interquartile range is the distance from the boundary of quartile 3 and quartile 4 and the boundary of quartile 1 and 2. So, and remember, it's a range, so it's this distance here. How far is that? So now what we have is the distance from 70 to 43.5. Okay, so we'll do some basic subtraction. how to find distance is different, so I'll have to carry the 1, got a 5, and that's going to become a 6 there. So 9 minus 3 is 6, 6 minus 2 is, or 6 minus 4 is 2. So my interquartile range is 26.5. So if you were to say the interquartile range, you would not say from 43.5 to 70. To say it correctly, you're actually going to have to say that 26.5. That is your interquartile range. And you can use that information to see the middle 50% of your data. And you can also use that information, and you should, to calculate outliers. But outliers, that's a whole other discussion, not for this brief video. So again, interquartile range is the middle 50%. Find the median, split your data in half, and then split those two halves in half, and take the top of quartile 1 to the top of quartile 3. And what is that distance?